My name is Yesenia Bermudez, and the problem I will be breaking down is from Chapter 15. The question states, what mass of ammonia chloride must be added to 250 milliliters of water to get a solution with a pH of 4.85? We are also given the equilibrium constant of ammonium. In simpler terms, the question is asking us to find the mass of a compound when we are given the pH, a constant equilibrium, and a volume. To start off, I think it's important to write the dissociation equation and Rice table to see what information you're given and what you have to find. We start off with ammonia chloride, which breaks down to ammonia ion and a chloride ion. From there, we take the ammonium acid and we add it to water, which gives us ammonium and a hydrogen ion. As we fill out the Rice table, we notice that we are not given an initial concentration for ammonia. So we're just going to leave that. We're going to label it as a capital M with a circle around it so that we can continue to write the Rice table. But the rest seems normal. We have zero concentration for both ammonium and hydrogen ion. Once we finish the Rice table, we can write out our equilibrium expression, which turns out to be Ka equals the concentration of ammonium times the concentration of the hydrogen ion over the concentration of ammonia ion. This translates to x times x over m minus x. In order to find m, we need to find first the Ka and the concentration for the hydrogen ion. The question gives us the equilibrium constant of the base, but we need the equilibrium constant of the acid. So to convert Kb to Ka, we can use the equation Kw, which is the equilibrium constant of water, is equal to Ka times Kb. In order to rearrange this so that we can find Ka, we have Ka equals Kw over Kb. When we plug in the values for this, we get that Ka is 5.56 times 10 to the negative 10. Next, since we were giving the pH, we can find the hydrogen concentration with the following equation. We have the concentration of hydrogen equals 10 to the negative pH. So once we plug in the numbers, we get that the concentration of hydrogen is equal to 1.41 times 10 to the negative 5 molarity, which is also equal to x. After finding Ka and the concentration of hydrogen, which equals x, we plug all of that information back into the equilibrium expression that we made in step 1, and we solve for m. After careful calculations and simple algebra, we end up with the value of m, which equals 0.359 molarity. The concentration that we just found is of ammonia, but we need the concentration of ammonia chloride. By looking at the dissociation equation that we wrote in step 1, we can see that 1 mole of ammonia chloride is equal to 1 mole of ammonia. So that tells us that the concentration of ammonia is equal to the concentration of ammonia chloride, which is 0.359 molarity. The final step of this problem is to use the volume and the concentration of ammonia chloride to find the mass in grams of ammonia chloride. We approach this step by taking the molarity of ammonium chloride, which is 0.359 moles over liters, and we multiply it by the volume, which is 0.25 liters, and we get 0.0898 moles of ammonia chloride, and then we multiply that value by the molar mass of ammonia chloride. Once we do that, we get the final answer of 4.8 grams of ammonia chloride. To recap the whole process that we just went through, we start off with number 1, write the dissociation equation and Rice table to see what information you're given and what you have to find. Step 2, you convert Kb to Ka. Step 3, with the pH that you were given, find the concentration of the hydrogen ion. Once you find those values, plug them into the equilibrium expression in step 1 and solve for the concentration of the desired compound. Then take that concentration and use the volume and its molar mass to find the mass of the compound in grams.